onto the rolling a die problem. Again, I've got a number of trials is 3 in the first instance, and my discrete random variable here, x, is going to count the number of 6s. So this time, the thing I'm interested in is number of 6s before it was number of heads. In this case, probability x is 0. Let me think what I need. To get no 6s, I need to fail, and to fail. So the probability of not getting a 6 is 5/6. I need that to happen 3 times. That gives me 125 over 216. Probability of x being 1. What do I need? I need 1 6 and 2 fails. I already know that there are 3 ways of doing that. 3 select 1, 3 choose 1 is 3. So I've got 3 lots of. This is where I have to be careful about successes and failures. The probability of a success in this case is 1/6. The probability of the failures is 5/6. So I need to split this into successes and fails. So here I've now got 75 over 216. Probability of x is 2. Let's go through this again. Tick, tick, cross. Again, I've got 3. I'm arranging 2 things. I'm selecting 2 things, sorry. Again, it's 3. So 3 lots of. Now this is where the symmetry changes. The previous question, this answer was the same as x is 1. But now it changes because I now need 2 successes and I need 1 failure. So giving me a different answer this time of 15 out of 216. And probability x is 3 is going to be, I want success, success, success. So 1/6 to the power of 3 is just 1 over 216. And I just want to sum these. 125, 75, 216 adds up to 1. So I'm confident that's okay. So those are my answers for number of trials being 3. Let's move on and extend to number of trials 4. You should be able to do this from yourself. Now, if you needed that as the hint, let's go. Number of trials is 4. Probability of x being 0. I need 4 failures. Fail, 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 fail. I like this just to help me understand what I'm working out. 5/6 to the power of 4 is whatever that comes to. X is 1. It's the structure that I'm interested in here. I'll let you do the calculations. I need, that's 4 choose 1, which is 4. So 4 lots of 1 success and 3 failures. Whatever that comes to. X is 2. Tick, tick, cross, cross. 4 choose 2, which was 6. So there are strong similarities with the previous question with the coins, but the big difference is the success and the failure. 6 lots of success twice, fail twice. Probability of x is 3. Tick, 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 cross. So that's going to be 4 ways of doing that. 4 lots of 3 successes and 1 failure. And probability of x is 4 is going to be tick, 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 tick. So success 4 times. If I add all of those should come to 1, and I've solved the problem for 4 trials. So now that we understand the way that this works, it should be a short step to solving for number of trials is 10. So if I've got now probability of x being 1, I need 1 tick and then 10 failures. I know by now that's 10 select 1 lots of. How many successes? 1. How many failures? 9. Whatever that comes to is my probability. I can do this for any number. X is 4. I'm going to want tick, 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 cross, cross, cross the rest of them. So 10, select 4 ways of arranging those things there. And then I want 4 successes. So I then need 6 failures. I'm noticing that all of these, 1 and 9 makes 10, 4 and 6 make 10. So I'm spotting little relationships as I go through. So that would solve it for 10. Let's finish off with a general formula. If my number of trials is n, then the probability of x being r, let's exploit the patterns. I want n, choose r. That's to account for the ways of arranging the successes and the failures. I've then got to make sure, how many successes do I get? It's given in the question. But if I get that many successes, I've then got to match it with the corresponding number of failures. In this case, I've got to make sure these two numbers add up to n. So it's going to be n minus r. And that gives me the general formula for the rolling a die question.